Let's start with number 4. So in 4, we need to find the arc length of the measure of the arc BC. So looking at this circle, it's important that you know that straight lines are 180 degrees. So here, since we have a straight line, all of these 3 angles are going to add up to 180. We have a right angle here, which is 90. So that would mean that these 2 angles left are going to add up to 90. So we can do 90 minus 49, and that would give us 41. So BC would be 41 degrees. And now for BED, so we're going to go from B to E, then to D. So we have a major arc here. BED is talking about the whole arc, everything except this part here. So everything but this part. So we know that the whole circle adds up to 360. So we're going to do 360 minus this part, so this arc. And we know that that arc is 90. So 360 minus 90 gives us 270. So BED is 270 degrees. Any questions on that one? All right, let's go to number 6, looking for SR. So again, we know that since we have a straight line here, arc SR and arc RQ are going to add up to 180. And it tells us what RQ is, so we're just going to do 180 minus 71, which leaves us with 109. So SR is 109 degrees. Okay, and now we need to find arc SQR. So we're going to go from S to Q, or SQU. So S to Q, then to U. So we're looking for this arc, which there's different ways that we can solve this one. So we can either do 360 minus the part that's not included, or we can find out what this angle is and add that to 180. So if we find out what X is here, we know that this is a straight line, so it's going to be 180 minus 40 minus 71, which leaves us with an angle of 69. So this angle here is 69, so I'll just put it up here because the arc is the same thing, so 69. So now we just add 69 to 180. And that gives us an angle of 249, right? So 249 degrees for arc SQU.
Well, Miss Carver, what I did, so I added 71 plus 40 and I got 111, and I minused that from 360 and I got 249.
Yep, like I said, there's more than one way to do this. So what Allie did was she found out what this arc is and then did 360 minus that, which definitely you can do that too. All right, let's go to number 8. So for these types of problems, we have to draw our little right triangle and find the missing piece. So we have a right triangle here. We know our hypotenuse of this right triangle is 7 because this radius of the circle is 7, so this radius has to be 7 also. And then we're going to find our missing piece of the triangle here, which we can call x. So we're going to do the Pythagorean theorem. So we have 4 squared plus x squared is equal to 7 squared. So 4 squared is 16 plus x squared is equal to 49. Then we subtract 16 on both sides. So x is equal to 33. X squared is equal to 33. And then we need to take the square root of both sides. And we get x is equal to 5.7, I believe. Let me do it in my calculator.
I got 5.74.
Perfect, 5.74. And then, so this is just this part, but our question's asking us for JK, so this whole line. So we just need to multiply 5.74 times 2. And Allie, what'd you get when you multiplied it by 2?
I got 11.49.
Perfect. So JK is 11.49. It says round to the nearest tenth, so it would be 11.5. Because the tenth would just be one decimal. So 11.5. Any questions on number 8? All right, number 9. So we're going to draw our little right triangle here. It tells us that UV is 8, so that would make this line 8 also, because it's also a radius of our circle. And then this half of it, our leg of this right triangle we have, would be 4, because this part is equal to this part. And now we're going to do Pythagorean Theorem. So we have 4 squared plus, we're going to call this part x, so x squared is equal to 8 squared. So 16 plus x squared is equal to 64. We're going to subtract 16 on both sides. So you get x squared is equal to 64 minus 16, which is 48. And then we take the square root of both sides, and the square root of 48 is 6.9. And then to find what xy is, this whole part, we're just going to multiply 6.9 times 2, which gives us 13.8. If you rounded it to 13.9, that would be correct also. Any questions here? Okay, another one I wanted to look at is 14. A lot of people on the homework skipped this one, but you might see something just like it on the quiz, so I wanted to do it. So we're trying to find the length of the semicircle, the length of the arc in a semicircle with the diameter of 92 meters. So our length of an arc formula is 2 pi r times the measure of the arc degrees over 360. So it gives us our diameter. So the first thing we need to do is find our radius. So we just divide 92 by 2, and that gives us a radius of 46. So we plug that in for r. So we have 2 times pi times 46. And then our measure of the arc degrees, it says it's a semicircle, so that means it's 180 degrees divided by 360. So if we put all this into our calculator, our length in terms of pi is going to be 46 pi. And then if we multiply 46 times 3.14, we get 144.44. And both of these would be in meters. On the quiz on Monday, it'll be specific on what it asks for, so it'll either say leave in terms of pi or round your answer. So it'll be specific on which one. Okay, so since those were the ones that you guys wanted to see in class, I'm going to go back and do the other ones now just so they're in the video. So for number 1, we need to identify each line or segment that intersects each circle. So for number 1, I'm going to write down all the lines that we have here, and then we can go back and name them, all the lines or segments. So we have segment PR. We also have line PR. We have segment PQ, segment QR, and segment QS. And then we have line M. Remember, if it's a lowercase letter, we only have to name the line by one letter. And then we have point R. Okay, so segment PR is our diameter because it goes through the center of the circle. Line PR would be a secant because it's a line that intersects the circle in 2 points. The next 3, so segment PQ, QR, and QS, these would all be radii. Line M, since it only touches the circle in 1 point, it would be tangent. And point R would be that point of tangency. Okay, let's look at number 2. So again, I'm just going to name all the lines and segments that we have here first, and then we'll go back and name them. So we have BE, segment BE, segment BA, or I'll just call it AB. We have segment AE. We have line BD. We have line CB. And we have point B. So BE goes through the center of our circle, so that is our diameter. AB and AE are both our radii. BD would be our secant, since it's a line that touches the circle at 2 points. CB only touches the circle at 1 point, so this is our tangent. And point B is our point of tangency. All right, let's go. We did 4, 5, 6, 7, 8, 9 in class. Let's go to 10. So this one was kind of tricky because we had to figure out what our measure of our arc is here. So looking at this circle, we see that if we count all of these dots that go around, there's 22 dots. And we know that the circle is 360 degrees. So we can find out what the measure of each of these dots would be. So if we did 360 divided by 22, because there's 22 dots, that would give us 16.36. So that would be what each sliver would be. So each dot would have the measure of 16.36. Now looking at our picture here, the angle that we're talking about, oops, let's erase this one. So looking at this arc, we have 5 dots. So I'm going to multiply this times 5 to find out what our measure of our arc is in this area that we're talking about. So I'm going to multiply 16.36 times 5, and that gives us 81.818, so I'm going to round it to 81.82. And now I can plug that into our formula. So we're using the area of a sector formula, so our area is going to be pi r squared times the measure of our arc degrees over 360. Our radius here tells us is 22, so we plug that in for r, so we have 22 squared, and our measure of our arc we said was 81.82, and that's over 360. And now we can just multiply this all into our calculator. So we have 22 squared times 81.82 divided by 360. And then we can multiply that times 3.14. So that gives me 345.4, which our question is asking us to round it to the nearest square centimeter. So I'm going to round it to 345. And then this is centimeters squared. So this would be our answer to number 10. Okay, moving on to 11. We're trying to find arc AB. So here we're looking for the arc length, so we're going to use our formula 2 pi r times the measure of the arc degrees over 360. Our radius is 4, and our measure of the arc that we're looking at is 150. So we're going to have 150 over 360. Now we're going to put everything into our calculator except pi because we want to leave our answer in terms of pi. So we have 2 times 4 times 150 divided by 360. And that gives us 3.33 pi. And then we're going to multiply 3.33 times 3.14 to give us our length rounded to the nearest hundredth. So we have 2 decimal places, so this will be 10.47. So we have 2 answers for this one. And then both of these would be feet. Let's move on to number 12. So here we're looking for the length of arc EF. So again, we're going to use our length of the arc formula, which is 2 pi r. Measure the arc degrees over 360. We have 2 pi times our radius, which is 2.4. Our measure of the arc is 75 degrees over 360. And now we can multiply everything together except pi. So we have 2 times 2.4 times 75 divided by 360, which would give us 1. So here, in terms of pi, our answer would just be pi. Centimeters, because we need our unit. And then our length rounded to the nearest hundredth would be 3.14 centimeters. All right, so this was 12, and then we did 14 earlier on in the video. So there is the quiz review.